So here are some of the points which we discussed, and a little more of that. So 81% organizations believe that successful adoption of IoT is critical to future success. Okay, even more than high-end technology. Leaders primarily look at growth and agility, right? And IoT is something which enables that. However, like we discussed, only 25% have clear IoT strategy, and leaders' biggest hurdles are data security, privacy, legacy systems, inability to do fast experiments, insufficient skill of IT staff. And above all, at the top of this pyramid, we have there is no clear strategy as to how to tackle some of these problems which is mentioned. So technology is not the root cause of the problem. Technology is pretty much fine. Like I mentioned, the challenge is always the strategy and also a clear vision as to how to adopt and scale an IoT system. Before I move on to this, so far whatever you have understood, give me one practical challenge you are going to face if tomorrow morning you are asked to create an IoT environment or IoT strategy, one practical environment, one practical challenge, sorry. So I have these sensors and I have this server. What challenge do I potentially face in implementing IoT kind of a service? It can be industrial, it can be non-industrial, does not matter. What is the challenge? Lack of data, anyways, your sensors are collecting the data. I think Merlin has got it correct. Seamless networking. So between the devices, how does it move from your sensors to the computing body and from the computing body to the action device? All right. For that you need networks, and the world is trying to solve these problems on various kinds of low load network optimization solutions, etc. and all. But nevertheless, realize that that is one of the biggest bottlenecks. On the same lines, there is another bottleneck. Can you guys quickly think of it? Security, privacy, that is fine. We can take care of that. You have HMI and SCADA systems for that. That can be taken care of. What else? Energy requirement, yeah, that's also taken care of. We don't really struggle with that. What else? What else? Something on the same line. Something on the lines of connectivity. Speed, loss of data, almost there. So let me help you out with this. The rules, what we call the protocol. Different devices have different data transmission protocols, right? So I want my mobile phone to talk to my car and probably the fridge, and these are different manufacturers belonging to different industries. So how do I ensure that they all follow the same rule? We need the same rule, right, to have this communication happening. So let me put it even more simply. I need a common language to talk to a person, right? And similarly, these devices need a common language. As of today, there are big conglomerates between bodies where they're trying to establish this protocol, also known as the IoT protocol wars. So the groups of big companies which have formed. I'm part of the Industrial Internet Consortium, which is coming up with the most advanced and probably the most optimal test beds for IoT protocols, all right, and architecture. So that is another challenge, that we do not still have a common protocol or a common set of rules, or in further simple language, a common language to talk between the bodies. So how are companies currently using Industrial Internet of Things? This is for your pursuit. I'll give you guys a few seconds to quickly run through this. I'm not going to walk you guys through this. This is examples. I have further examples coming down as I move down. So take a few seconds, absorb what is there. I have a few applications in transportation, manufacturing, retail and finance, utilities, healthcare, security, and consumer services. All right. So somebody asked me, is AI involved in IoT? Please hold on to that question, and I would like to take that at the end of the session. All right. So here's a representative example from Power Generation Word. My challenge is limited access to data leading to partial operational insight. What I mean by it is I am not able to access all my data, and even if I can, they are not all structured. Okay, and I am not able to access them in real time. So I have a turbine, okay, and it runs day in, day out, and I'm collecting that data of what are the statistics on it. And this all data gets stored in some data warehouse or some server warehouse. And later on, an analyst would download this data, do various kind of analytical statistical modeling on it, and then probably send the insights. There's a lag between them, right? Between the data was generated and between this decision making happens. That is called post facto analysis of faults and repairs. It is costly on-site repair and high unplanned downtimes are involved. Think of our aeroplane with the 4 engines example, that this event happens and the next day one analyst does the analysis on the numbers which you have got from the engine, and the day after we try to solve the problem, right? It does not make sense. IoT solves that particular challenge. So how do we solve it using this? We have remote troubleshooting available, connected assets eliminating manual intervention, data to insight action loop, which we just discussed, new capabilities, diagnostic algorithms, condition-based maintenance, remote fix, critical spares planning. Right? What happened when we did this? The solution. What was the impact? All right. 40% reduction of maintenance cost per unit, 30% reduction of downtime and unplanned outage. What is an outage? Anybody? Okay, you have to forgive me for this. I belong to industrial manufacturing, so I use this term. Apologies for that. Failure events. Fantastic, Thomas. Thank you for that. And so any event, basically when we try to repair, or any event which is done to repair, inspect, etc. with these machineries, we usually use the term outage. It can be planned or unplanned. When I say planned, think of your car which is going for service. It is a periodic service involved in that, and so on and so forth. All right. And an unplanned, when your car meets an accident or has a breakdown in the middle of the road, that is an unplanned. So 30% reduction in downtime and unplanned outage because it could be fixed on the fly. Elimination of false alarms, lower inventory and warehousing, costly costs, and optimal field service planning. I do not think I want to get into the technical details of how this machinery works in terms of industrial internet. All right, but like I said, this is for your own pursuit, and we can probably connect another day on this. In a very simple way, the diagram which you see on your screen belongs to a particular IoT enabled platform called Predix, which is generated by one of our partners, GE. And this is a windmill diagram. So if you see, the windmill is generating the data which comes from Predix Machine Software Analytics. This Predix Cloud has data infrastructure layer and Cloud Foundry, which does the cloud computing bit of it. And it has a top layer which talks about assets, analytics, data, security, and operations. And this platform can cater to almost all major industrial groups such as energy, healthcare, transportation, and industry.